Hello class, welcome back. This will be lecture number 18 in the PowerPoint. So you can see this is the Geography of Soils part number 2. So you remember in lecture 17 that you just watched, we had a classification system that we had talked about. So we're just going to continue on with that today. The first part, remember, was all about the properties of soil. So don't forget any of those. We're going to be going through some of those. And some of the basics of soil formation, the organic and inorganic materials. So that's what we're going to continue with today, and that is the soil classification system. So this shouldn't take too long, but there are some subtle differences between each of the soil types. And there's certain things I'm going to want you to remember for the final exam. And I have a review for the final exam at the very end of this lecture. So as you're flipping through these slides, if you pull out the last slide, it's going to have a nice little summary for you. So you can kind of follow along, maybe take some notes on that summary slide. So we're going to talk about, if you remember from the end of lecture 17, is soil taxonomy. And that's all this lecture is on, is soil classification. Basically, we'll be looking at the soil horizons, the soil orders, how they're classified, where you're going to find these, and how they're related to climate and other variables that control where these things are found. So this is the map that I left you with in lecture 17. This shows you the main 12 soil orders that we see out there. They're all listed there to the left on this graphic. Basically, if you remember, we said climate was the big controller of where we find these soil types. So again, if you look at soils in North Carolina, very similar to the soil types that we see in areas of China, right? Some of these rainforest areas here in Brazil, rainforest areas of Central Africa. Same soil types, same climate zones. So the goal is, again, in this lecture, is to break these orders down and talk about some of the main ones that we see out there. Now, I used to go through all 12 soil orders, but in the interest of time, in the interest of keeping it really, really interesting, I decided to pick out the top 6 or 7 ones that you're likely to see around the world if you travel someday. So that's what we're going to go through. The textbook has a really nice summary slide that's labeled here. This is table 11.1. This gives you the root words of where all these soil types come from. So when you hear me going through all of these soil types today, you might think, where are these words coming from? They're basically all Latin and Greek origin words, a few others, but they mean something. Like take the second one, for example, Aridisols. The word arid meaning dry. So that's going to be your dry desert soils. So that's kind of how this is classified and how these are broken down into their sub components. So use this as a reference sheet. So if you're ever curious where the words came from, it's a great reference sheet that has those word origins associated with it. All right, so that's what we'll see. So we're just going to jump right into it. And again, all of these are the ones I want you to know for the final exam. So I don't want you to know all 12 of them. I want you to know these top 6 or 7 that we go through. We're going to go through each one. Each one is going to have 3 components that I want you to remember. I want you to remember the name. So for example, in this one, Ultisol, you can see there. What's in quotes next to it is also very important. I want you to remember that. That's kind of the where is it, or the description of the soil. So you can see there, Ultisols are what we call tropical soils, right? And that's going to be their classification. And then each of the soils usually have something special or makes it unique, and I'm going to want you to know that as well. So let's talk about an Ultisol. Ultisols are tropical soils, like I said. So these are going to form in the tropical zones of the world. So the rainforests of Brazil, the rainforests of Africa, and some of the Philippines areas. What they are is they're the result of places that see really a lot of rainfall. So if you live in the rainforests of Brazil, as we talked about in the climate lecture, you get copious amounts of rain, 1 to 200 inches of rain per year, 3 to 4 times the rain we see here in the Carolinas. What that does is most people think, oh, you get a lot of rainfall, the soil is going to be super fertile, lots of things can grow there. That's actually quite the opposite. When you have lots and lots of heavy precipitation, what this causes is what we refer to as leaching in the soil. So imagine you have the soil and you get all this rain. The rain's falling down, it's hitting the soil, and the water percolates down through the soil. But imagine that every single day water keeps draining through the soil. The soil's nutrients will just keep getting picked up by the water and carried away. So leaching is just that, when water is draining the soil of its nutrients, and that's what we see. That's an Ultisol type of soil. It's a lot of rainfall, draining the soil, leaching the soil of its nutrients, making it not very fertile is what we see, right? So this is why in the rainforest areas, people chop all the trees down, they burn them to add all of those nutrients to the soil, which makes the soil very fertile, and they plant crops, but then in 2 or 3 years, nothing will grow there because there's so much rain, it just drains those regions of all of its nutrients, And what do? They chop down more trees, more forests. And this is why deforestation is such a huge issue in those South American regions, because of this leaching property of the oxisol type soils. So where are they found? You can see in this graphic, it shows you these tropical areas of South America, tropical areas of Africa, a few little spotty areas in the Philippines where we see quite a bit of rainfall as well. There's a better picture of it for you here, and it tells you that it's about 8% of Earth's land surface are these oxisol type soils. Very poor fertility, as it says there. They form in the warm, moist zones of the world, get lots of rainfall, and it drains those soils of its nutrients, as it says there, leading to poor fertility. Notice it also creates this what's almost known as brick-like soils, so you get very, very rich soils, very deep colored soils, because it's mostly all iron in many of these regions, is what we see. So that's what I want you to remember. Oxisols are tropical soils, and they experience leaching. So that's how you'll be asked this on the final exam. So what will I know? You need to know those three things: oxisols, tropical soils, and leaching. All right. The second type of soil type that we have are, as I mentioned earlier, the aridisols. And these are the ones that the students usually love the most, because aridisols, the prefix there, arid, easy to remember, arid meaning dry. So this is the desert soil orders. So this is the very, very dry areas, parts of Africa, parts of Australia, parts of the desert southwest in the United States. They're known as a desert soil. They occupy about 20% of Earth's land surface and about 12% of the U.S.'s land surface. So they are a huge chunk of Earth's land. So it's about a fifth of Earth's land surface are these aridisols. It shouldn't be a surprise, because if you remember back in the climate lecture, the climate zone that was the dominant one was the desert climate zone. So it's not a big leap there to understand then that the desert soils are the largest soil order. The third bullet point there says when you have a lack of water, so it doesn't rain much, you don't have much plant life or animal life. So there's not a lot of organic material. So from lecture 17, remember we said that O horizon ranges somewhere between 20 and 30%. This is going to be a lot less than that, because there aren't a lot of plants there, so there's not going to be a lot of organic material in the soil to begin with, right? So the thing that this suffers from is what's called salinization. So like in an oxisol, you had a lot of leaching because there was a lot of rainfall. In an aridisol, it's kind of the opposite problem. There is no rainfall. So any water you have in the soil evaporates out, and what's left behind are all the salts and minerals that were dissolved in the water, and that's what salinization represents. It's a lot of evapotranspiration, a lot of evaporation out of the soil. When it evaporates in these arid regions, it leaves all those salts and really kind of bad minerals behind. And salty soil, even if it would rain there, plants just won't grow in it. So even if it would rain in the desert this year, plants are just going to start springing up because the soil is just too salty for it. So aridisols they're the desert soils of the world, and they suffer from salinization is the idea. All right, so just to give you some pictures, aridisols make up about 12%, as you said, of the U.S. land surface, about 20% of the world's land surface. This next graphic is a little bit better. It shows you the brittle nature. Just look at that soil. It just looks super dry, very brittle throughout, very little soil moisture throughout. And notice how much of the world's surface it covers. The western United States and Canada, all around the Sahara Desert, Saudi Arabia, parts of China and Mongolia, Australia, the southern parts of South America. Huge areas of Earth are covered by this, right? Almost 20%, or about a fifth of the world's land surface. So aridisols, desert soils, salinization. That's the thing to remember from these slides. So if we cut across the United States, so notice we start over here in the western U.S., near Colorado, New Mexico, Wyoming, these regions. And if you travel from those areas to us here in the Carolinas or parts in the eastern United States, it's going to look very different soil-wise and plant-wise. So what these next graphics are going to show is a cross-section of the United States from those Rocky Mountain regions all the way eastward to the eastern coast of the United States. So if you do this, so if you look at this graphic, it shows you from Wyoming all the way over to maybe like Michigan or Indiana or Ohio. What it looks like in cross-section is this top graphic. This darker shading area here, this shaded in area, this is showing you areas of soil that have a very low pH. pH is less than 7, so this is a very acidic soil. But notice what happens. As you head out west, that layer of acidity is very, very tiny and thin. But the farther east you get, the deeper and deeper the acidity goes. Why does this happen? Well, look at the plants up here. The plant life in the eastern United States is huge. Look at this lower graphic. This shows you plants from this Midwest area. It's all green and lush, lots of vegetation. Where there's a lot of vegetation, there's a lot of acidity. Look at this over here, this lower left picture. These are the foothills of the Rocky Mountains, so eastern parts of Wyoming or Colorado. Look at the level of vegetation there. Hugely different. This is super, super small amounts of vegetation. Where there's a little vegetation, there's not going to be much acidity. So this is going to make a big gradient of acid soil across the country, meaning acidic soils here where we are, and then very, very low levels of acidity out west. So there's a big difference in the soil types across the country. And you can see the reflection of that in these two lower images. Very, very low amounts of vegetation versus very, very lush, green, very acidic vegetation out east where we live. So that leads us to where we live, which is the next slide, which are Ultisols. Ultisols, as it says there, are highly weathered forest soils. This is the soil classification that we have here in North Carolina. So when you leave campus, you leave your house, you're walking around, the soil that's under you is an Ultisol. And in quotes there, it says these are highly weathered forest soils. So what does that mean? Highly weathered. So where does our soil come from? The Appalachian Mountains are to our west. When it rains, all of that mountain area gets eroded away, flows downhill, and creates the soil that we have here in the Piedmont and in the coastal plain. So it's highly weathered mountainsides. And it's a forest type soil. So that means the dominant type of vegetation that grows here in North Carolina are trees, right? So a lot of our soil, the organic material, has come from trees, different oaks and maples and different pine trees if you're in the mountains. So that adds all that organic material to the soil as well. Now, Ultisols, because here in the south and in the east we do see more rainfall than in many other parts of the world, we do have a good bit of leaching that occurs here. Now, it's not the leaching that we see in the rainforest, but it is there. This is why agriculture and farming is much more efficient when you're in Ohio, all the way out to Nebraska, where they get a lot less rain than we do here in the southeast. I realize it seems a little bit counterintuitive that we get more rain here, so shouldn't you be able to grow more crops? It's actually the opposite. You need that balance. You need just enough rain to form crops, but you don't want too much to leach the soil nutrients out of it. So Ultisols, we still grow things here, of course, but it's a little bit tougher here than it is out in the Midwest and the Central Plains of the United States. The other thing about Ultisols here, this third bullet point, it says that our areas of agriculture have been damaged by certain crops. So in the South, we've had a lot of farming over hundreds of years, so it's the oldest part of the United States here in the eastern side. And through the years, we've planted tobacco and cotton, other very damaging crops. And when I say damaging, I mean when you plant tobacco or cotton, it drains a lot of nutrients out of the soil. And then you get rid of that tobacco, and then you plant more tobacco, and it keeps growing and removing all those nutrients. So it keeps removing the same nutrients. So it's that soil degradation we talked about in lecture 17. It is really, really, really prevalent here in the South because it's so good for money to keep planting tobacco. It's a cash crop. You make a lot of money off of it. So they didn't want to rotate those crops out. So when you don't rotate, you drain it of its nutrients. So that's what's happened to a lot of our farmland in the South and in the eastern United States. This graphic here shows you the soil map of where these similar soils are around the world. So you see southeastern United States, southeastern parts of Asia, around the rainforest areas here in Africa, around the rainforest areas of South America. So we all share very similar climates in those regions. Similar climates, similar soil types. You see a picture down there, this could be like North Carolina. You see it's mostly trees. You see this clay-like soil here that's under there. That's very, very representative of an Ultisol that we see here in the southern and eastern United States. Right, it makes up about 9% of the land area, as it says there. It's more fertile than a rainforest, but because there's less leaching than an oxisol, but there still is leaching. So when you have leaching like this, you're still going to have a reduction in the fertility of the soils. Right, I have so that's the map there. So it's 9% of the land area is what we see. Okay, so there's that one. The next one in the soil classification scheme here is what's called the Spotisol. Spotisols, as you can see in quotes there, is a northern coniferous forest soil. So what is a conifer? Here in the South, we don't have too many conifers. Most of our trees are deciduous, meaning they lose their leaves. Conifers are pine trees, basically. They're evergreens, they're needle leaf trees. They keep their needles on them all year long. Now this has big consequences. So where are these? First of all, the northern US. So if you ever travel to Vermont, New Hampshire, Maine, southern parts of Canada, in Quebec or in Ontario province, in those areas, there's a lot of pine trees. What pine trees do is because they have needles on them all year, they're constantly blocking out the sun. So as it says there, it creates a shaded area. The soil's never really experiencing sunlight. So it keeps it moist and cool all year long. And it's a cooler climate too. So you have cooler soils, you have wet soils, it's moist all the time. So this gives you very acidic soils. Right? So that second bullet point, these are highly acidic soils. One, because of the climate regime, but more importantly, because pine trees are very, very acidic. If you've ever seen in a neighborhood, in an apartment complex, or somewhere on campus, they'll use what's called pine straw. They'll put all this pine straw all around the shrubs and these decorative areas. Weeds don't grow through it. Why? Because when those pine needles break down, they are super, super acidic. So they make the soil acidic and plants have a really hard time growing in this. So agriculture is really tough. The third bullet point there says if farming is attempted, you have to add a lot of base to the soil. So if you're gonna try to farm, you have to add a lot of lime or something to neutralize that really low pH. And the other thing that makes farming difficult there is the climate zone. It's cold there throughout a lot of the year. So if you go up to Maine, you're freezing, you start to get below freezing in September, and you don't stop getting below freezing until May. So the growing season is very reduced in those spotosol regions. Right, this shows you where they're found. So it's only about 3% of the land area. So you can see the northern tier of the United States, southern Canada, parts of some of the Nordic countries, so Norway, Sweden, Finland, those are areas of similar soil types to these. You can see it's very damp. It has a very damp look to it, very, very high acidity because of those pine trees. So very acidic, very infertile types of soils where lots of conifers and pine trees develop. This is a zoomed in image to show you the soil profile. Again, I don't care that you can identify soil types. That's really beyond the scope of this course. But you can kind of get that look that this is something you'd see in a very dark, damp kind of development area, and that's the soil type we see. You can see this in the northern US, southern Canada, and again, parts of northern Europe. Those similar climate zones, similar tree types, so similar soil types is the result. So those are spotosols. The next one are referred to as Entisols. Entisols, they're a really unique one. Of all of the climate relationships that we have with soil types, this is the only one that doesn't have one. Entisols can form anywhere, in any climate regime. So as it says, these are not climate dependent, as it says in that second bullet point. These are recent undeveloped soils. It's actually easier just to show you the picture. So if you skip 2 slides ahead, you can see this is a picture of an entisol, right? You might say, well, this doesn't look like soil at all. It looks like a whole bunch of rocks. And you're right, it is. But if you notice in these little valley areas, you can see this little bit of sediment that's starting to accumulate here. Weathering and erosion is breaking down these rock faces, and you're starting to just see a little bit of sediment forming in those areas. That little bit of sediment that's forming, that's your beginnings of soil. There's no depth to it, there's no horizons, there's no different layers. It's that initial beginning developments of soil. So to go back, as it says, these are recent, undeveloped soils. So it's just brand new sediment that is accumulated in those areas. They are a soil type. You can clearly see there was some sediment accumulating there, but they don't have any horizontal layers. There's no depth to them. You can't farm in them, and they're really, really difficult to do anything with, really. This shows you, the next slide shows you kind of a cross section. So you can see this. This is all solid rock, solid rock, solid rock. And notice at the very top, it's just starting to break down through weathering and erosion. So it's just starting to form a soil type. Right? And this shows you a more advanced one where just a few plants are starting to pop up through this. But it's very, very difficult. It's about 16% of the land surface. This makes up like much of the Sahara Desert is this. It's just rock. Most people think, oh, the Sahara Desert is just covered in sand. In fact, most of it is just rocky areas that are very undeveloped, very young types of soils. And they're really slow to develop because in these desert areas, it doesn't rain much. So you're not going to have a lot of rain. You're not going to have a lot of weathering and erosion from all those rain properties that we talked about in lecture 16, right? So it's very difficult to form. But they form all over the place is the idea. All right, so the very next one on here are called the gelisols. These are, as we said, this soil classification system started in the 70s and then was revamped and updated in the 1990s. This is one of the ones that they added to it late in the 1990s. This is the Gelisol. It's, as it says, the newest addition to soil taxonomy. This is referred to as, in quotes there, the cold, frozen soils of the north. These are the soils of Alaska, Canada, parts of northern Russia, where it is super cold. It's those tundra climate regions where it's below freezing for 8 to 10 months of the year. But we do have that 2 or 3 month period where it does get above freezing, the snow melts. So you do have some small cold weather plants and organisms that live there. Most of the vegetation that grows here is either lichen or mosses and other cold weather creatures that can survive in this type of environment. So where is it? You can see Alaska, northern Canada, extreme western parts of Greenland, northern parts of Russia. A better image of this, again, it's 9% of the land area, is this picture. So it shows you the same map, but it shows you what northern Alaska looks like. Most people think northern Alaska is just covered in snow and ice. And that couldn't be farther from the truth. The reality of it is it is covered in snow and ice for much of the year, but in a tundra region, it gets above freezing in June, July. It'll be into the 40s, maybe in 50 degrees. All that snow and ice melts, and you can see there's stuff growing here. This is mostly moss, and when you lift the moss up in this right image, you clearly see there's soil underneath this. But it's a very slow to develop soil, very, very slow. Because when this moss dies, or let's say there's a polar bear that dies and it's starting to decompose, then it drops below freezing for 10 months. And as most of you know, when you're below freezing, it doesn't decompose, it just sits there frozen. And then it only has the decomposition process for those 2 or 3 months of the year. So it's a very slow to develop soil as well, is the Gelisol. So it's the cold frozen soils of the north, the newest soil order, and it's very, very slow to develop because of that freeze-thaw process that we go through. Now the final soil type on our soil list is referred to as the Andisol. It's a unique one. That's why I like to throw this one in here. You don't see it very often. It's less than 1% of the total Earth land surface. But these are the volcanic soils. Right? These are soils that were created from a volcano, either in recent times or an ancient volcano. Basically, you get a volcanic mountain, and on the side of the volcano, all that ash and lava and debris that accumulated from the volcano, over time, weathering and erosion breaks that up, and then the soil that is created is mostly made of volcanic material. And when you have volcanic soil, what it's able to do is, as the third bullet point says here, it stores a lot of water. So the unique thing about volcanic soils is it can store tremendous amounts of water. And if you think about a pineapple, for example, many of you probably enjoy pineapples. Pineapples grow primarily in Hawaii. Why do they grow there? Because Hawaii is a volcanic island, and the soil that exists in Hawaii can store lots of water. And pineapples, like sugarcane and other types of plants, demand tremendous soil moisture, right? So what you need then is a soil that's able to hold a lot of water. So this is why pineapple plants don't grow all over the world. They grow in these very specific volcanic types of soils. So it's a very unique one. So where are they? Oh, well, they only make up about less than 1% of the land area because you need volcanoes in order to produce them. So you see they make up a little bit of the Pacific Northwest, kind of near Mount St. Helens, down near Mexico City, down through the Andes Mountains. There's Iceland, there's some of the Philippines, there's Japan, there's New Zealand. Hawaii would be on this graphic, but it's kind of on that divided line. That's what they are. Again, you don't need an active volcano. You just needed to have a volcano sometime in the past so that the soil is made up of at least 50% or so of volcanic material is the idea. All right, so that's what an andisol is. So you can see this shows you parts of Iceland, huge agricultural areas. All right, they're storing lots and lots of water in the soil. You see the livestock on the right, the agricultural fields on the left, huge farmland areas, so very, very fertile in these volcanic types of soils. There's just not many of them. They only make up, like I said, less than 1% of the soil areas. So the all-important question, of course, why are we all here, is which one do I need to know for the final exam, right? And as I alluded to in the beginning, this used to be more dramatic whenever I had all 12 of them that we went through. But since I have cut the list down, all of them that we went through is on the list, so it's not very dramatic. So this shows you all of the soil types. They're listed on here on the left. So again, remember, just as a quick recap, Oxisols, tropical soils, what do you remember about those? Leaching, drains the soil of its nutrients from all the rainfall. Aridisols, desert soils, very dry, so they experience what's called salinization. So remember, all that water evaporates out and you're left with all those salts behind. Ultisols, highly weathered forest soils, that's the soil we have here in North Carolina. Remember, this is the soil that's been drained of its nutrients from tobacco and cotton and things like that. But not as much as those rainforest areas is what we see. Those are Ultisols. Spotisols, remember, the northern coniferous forest. These are the pine trees where it's very damp, cold, moist all year long. Very, very acidic soils. Pine needles are acidic, so the soil is very acidic as well. Entisols are the undeveloped soils that we see out there. These can form anywhere. Remember, these are the ones that are non-climate dependent. They do not depend on the climate whatsoever. That's that Sahara Desert soil where it's mostly rocks, but just a little bit of soil starts to develop in those regions. Andisols, remember, these are the volcanic soils. This is the pineapple, the sugar that we just went through. Volcanic soils can store lots and lots of water, so they're very fertile to many types of plants, is what we see. And then the final one on that list is the gelisols. Remember, these are the newest ones added to the soil taxonomy classification system. These are the cold frozen soils of the north, right? They were most recently discovered. Remember, they're very slow to develop because of the freeze-thaw process. So when things decompose, it just takes a very long time to turn into that organic material. So these are the ones I want you to remember for the final exam. These will appear on the review sheet again, but make sure you have all of those third things on there because that's what we're going to go through on the final. So I'm expecting you to know all three things that go with each soil classification. All right, well, that concludes lecture number 18. Lecture 19, next time we'll be dealing with ecosystems. We'll try to wrap together climate and soil types and the hydrologic system and try to figure out what exactly grows in these regions. Well, have a good afternoon.